Hello guys, welcome to my YouTube channel. My name is Simbarashe Karambwe. Most people they know me by Simba. Actually, I'm gonna be here to take you through chemistry concepts called spectroscopy. So I'm gonna be discussing a particular question that will take you through infrared spectroscopy, the mass spectroscopy, and the NMR spectroscopy. So, well, I'm not an expert, but I believe I can help you because my experience, I've helped a lot of people with regard to this particular aspect. It's a module that I did in my second year, chemistry as an elective module, and in my class that time I was the one teaching people to understand spectroscopy. So I believe that I can do the same. I can make you understand. I can, break the barrier that is holding you in understanding spectroscopy. So basically there are some fundamental basics that one needs to understand in order to tackle this spectroscopy. So let's say given a question, so in this case I have a question that I'm going to try to take you through. Unfortunately, I'm not so sure if my camera is very poor, but this is the question. So we have the infrared information and the mass spectrometer information, the carbon NMR information, and the hydrogen NMR information. So I try to magnify the information. So I'm going to show you what's on that question paper, then we take it from there. So to begin with, if you are given that question, so to begin with is to look at the mass spectrometer. So in this case, the mass spectrometer information, the second diagram here from the top. So here I just indicated two important peaks that are of interest. So we have also the molecular ion peak. So I'm going to try to interpret that information and see how it is going to take us to get a clue about the compound that you are looking for. So in this case, rule of thumb, when you get the information about mass spectrometer, it helps you have an idea of the molecular formula of the compound that you're dealing with. So in this case, the parent peak, the M+, it will actually give you the clue of the molecular formula of the compound that you're dealing with. But normally the M+ ion is due to existence of an isotope. In this case, it can be the carbon isotope, or it can be the nitrogen 15, it can be the hydrogen, like for example deuterium, for example. But anyway, I don't have to spend much time talking about mass spec. So we are fortunate that we do have the molecular formula. So it's C9H10N2. So how do we take that information? How do we proceed with that information? The first step that you need to do is to find what is called degree of unsaturation. So I'm going to try to take you through on how you calculate the degree of unsaturation. So using that formula, we have the C9 H10 and 2. Okay, so the rule of thumb, remember, whenever there is nitrogen in your compound, you are supposed to subtract, for each hydrogen you subtract, so for each nitrogen you subtract a hydrogen. So in this case we have 2 nitrogen, so it means we're going to subtract yes, we're going to subtract 2 hydrogen as well. So how do we interpret this information? So you consider this part, C9H10, right? Then you think of the alkane that has got 9 carbons. So the alkane that has got 9 carbons is going to be C9H20. That's the alkane that has got 9 carbons. So we want to compare that alkane with this part of our formula. So in this case, remember I said we're gonna subtract 2 hydrogens because of the 2 nitrogens that we have. So in this case, it means we are simply going to have what do you call it? In our formula, we're gonna have C9H8. Instead of 10, we are subtracting 2 hydrogens. It's gonna be H8. So what we do now for degree unsaturation, degree of unsaturation, I'll call it du, is given by this 20, okay, subtract this 8, and we divide by 2. So you find out, we're going to find our answer is 6 degrees of unsaturation. So one rule of thumb, whenever you get a degree of unsaturation which is of this magnitude, 6 for example, or 5, quickly think of a ring, a benzene ring, because a benzene ring, it has got 4 degrees of unsaturation. So in this case it can be a benzene ring. Our assumption is to say we have a benzene ring, okay, because a benzene ring, it gives you 4 degrees of unsaturation, and probably we can also consider probably we have a triple bond, okay, because a triple bond has got 2 degrees of unsaturation. So this is one possibility that we want to look at, okay. This is one possibility that we want to look at. So this is how you interpret this information. So by so doing, then you are done using the information of the mass spec.